Hello everyone, I am Animesh from DV Public School NSC 95 Hyderabad. And today I am going to demonstrate or verify the concept of energy conservation. So, let's get started. So, here is the written part of the experiment. First, we have aim. Our aim is to verify or demonstrate the concept of energy conservation. That is, container, measuring instrument, and sand. We require only these three objects to verify it. In this experiment, we require some prerequisite knowledge. That is, the concept of energy conservation. You have to know a little bit of it. Then, the relation between the kinetic energy and potential energy. Then, the formula of kinetic energy and potential energy. If you don't know the formula, just wait few seconds. I will show you the formula and explain it to you. So, after the theory, we have the formulas which are used in this experiment, which is kinetic energy, potential energy, and total energy. So, kinetic energy, first kinetic energy formula, which is half mv square, where m is the mass of the object and v is the velocity with which the object is traveling. After that, we have the formula of potential energy, which is mgh, means the mass m equal to mass of the body and h is the height from which it is dropped. Total energy is equal to kinetic energy plus potential energy. Okay. Then we have SI unit of these formulas, which is joule for both of them. Then we have the dimension formula for both of them, which is m square, l square, and t to the power minus 2. So after that, we have the result. I have performed the activity and I will show you. So let's read the result. That is, though kinetic energy and potential energy differ at different time and different position, but the total energy remains constant. Then we have some precautions to perform this activity. First is the container should be clean. Second, sand must not be hard. And third one is the container must have wide mount. So let's go to the video and I will show you and explain it to you. So let's get started. You have to take a container filled with sand. Okay. Then I have taken an iron object and marked some rings in it because I don't do that, then I have to use a measuring scale again and again. So I put 13 rings at equal distance in the object. Let me show you. Then I have to drop it from different height. Why? Because let's take this as an object. When I take it to some height, it must have some potential energy because the formula is potential energy is equal to mgh. And I have taken the reference point, which is the ground at which I have put my container. So according to that, it has some distance between the ground and it must have some potential energy. And kinetic energy is equal to zero. Why? Because the body is not traveling any distance. So kinetic energy is equal to zero in this case. As I have dropped the object from some height, the kinetic energy start increasing. Why? Because it start accelerating. You can see that. Okay. Now this is in this experiment. So at this time, I can see only 8 visible rings. Means that the left rings are below the sand. Then I take it to some other height h2. Let us call this height h2. And when I drop that object, number of visible rings came down to 6. Means kinetic energy and potential energy increases when I increase the height. And let me take it to some height h3. When I drop that from there, I can see only 4 visible rings. What does that mean? This means when I increase the height, the kinetic energy, or you can say the potential energy, increases. And when it is dropped, kinetic energy start increasing and potential energy start decreasing. Okay, and I want to add a note that kinetic energy plus potential energy is equal to total energy, which is constant. So with this example, we have verified the energy conservation concept. So that's all for today. Thank you.